In aldol condensation, it was given by aldehyde and ketones that have alpha hydrogen. Okay, and those who do not have alpha hydrogen, they give Cannizzaro reaction. Is right. Cannizzaro reaction. Is right. Shown by aldehyde and ketones with no alpha hydrogen. Shown by aldehyde and ketones with no alpha hydrogen. Is right. In this reaction, one molecule is oxidized to carboxylic acid, and another molecule is reduced to alcohol. And in the presence of concentrated alkali, in presence of concentrated KOH. Okay, so for example, you have HCHO. Here the functional group is CHO and there is no carbon attached to the functional group. That is why there is no alpha carbon. If there is no alpha carbon, there will be no alpha hydrogen also. In the presence of concentrated KOH, it forms HCOOH, but since it is in basic condition, it will form the carboxylate ion and K positive. Okay, it will form the salt here. And it also forms CH3OH. That is one alcohol and there is one carboxylate ion. If you just add water to it in acidic condition, you will get carboxylic acid, but same thing, oxidation has happened here. Similarly, if you have benzaldehyde, benzaldehyde, it has CHO, that is the functional group. It is attached to this carbon atom, and this carbon atom already has 4 bonds, so there is no hydrogen on this carbon atom. So alpha carbon is present, but it does not have any hydrogen. That is why 0 alpha hydrogen. And this is also going to give you concentrated KOH. Benzoate ion, this CHO will convert to COO negative and K positive, potassium benzoate, and it will also give you benzyl alcohol. You'll have CH2OH. Please write this down. After writing the reaction, write the last type of reaction that is shown by aldehyde and ketones, and especially benzaldehyde and acetophenol, electrophilic aromatic substitution. Electrophilic aromatic substitution. Right here, aldehyde and ketones are deactivating. That means they pull electrons from the benzene ring, and meta-directing groups. And meta-directing groups. That is why substitution occurs at meta position. Those who are late, please take a screenshot. Please take a screenshot here, and then you will write whatever is after electrophilic aromatic substitution. Take the screenshot of Cannizzaro reaction. Deactivating लिखा है ये. This is deactivating. This is deactivating. If you see the resonance of aldehyde and ketones, no? Both will have C double bond O, and there will be H or R, whatever group will be present here. Okay. So if you have C double bond O, and then, for example, you have H, or you can have R also. If you have H, it is aldehyde, R if it is ketone. So in this case, the resonance happens like this. And as you can see, what is happening here? The group, it is taking the electrons away from the, benzene ring. And it is giving positive charge on the ortho and para position. That is why the substitution, it happens at the meta position. Deactivating का मतलब है that the electron is going away from the benzene. Up to that point, we'll see first of all the reactions that are given by aldehyde, aromatic aldehyde, that is benzaldehyde, CHO. So there are three reactions that we need to remember. It gives chlorination, it gives nitration, and it also gives sulfonation. In the presence of chlorine and FeCl3, it gives meta substituted Cl, and the CHO is as it is. In the presence of concentrated HNO3 and concentrated H2SO4, it shows nitration, in which nitro group is present at the meta position, and CHO is as it is. Then concentrated H2SO4 will give you sulfonation, in which SO3H group is attached at the meta position of CHO. Write this down. There are other resonating structures that can be formed. Okay. Just need to keep moving the electrons like this. And there will be positive charge here. Then this will move, then there will be positive charge here. See, similar type of reaction also occurs for acetophenone. The only change will be this will be carbon doubly bonded with oxygen and a single bond with CH3. This is acetophenone. It will show same reactions. Just need to change the groups. Yes, correct. Alpha hydrogen means a hydrogen attached to alpha carbon. Let me know if you are not done. If you're done, please write the next topic. Method of preparation of carboxylic acids. Now in this slide, the first method of preparation, that is oxidation of 1 degree alcohol and aldehydes. Okay, so we know that if you have 1 degree alcohol and you use a strong oxidizing agent, then it will give you carboxylic acid. Carboxylic acid, I will sometimes write it as Ca. Okay, it will give you carboxylic acid. So what are the strong oxidizing agent that you can use? You can use your K2Cr2O7 or Na2Cr2O7. You can also use KMnO4. And the last one, which is important, CrO3 in the presence of mineral acid, H2SO4 or something like that. Okay, this is known as Jones reagent. Please remember this. Mark this as important. Jones reagent. You can be asked in 1 mark question, what is Jones reagent? Okay, so Jones reagent on 1 degree alcohol, it gives you carboxylic acid. Right, next. Similarly, aldehydes can be converted to carboxylic acid using strong and mild oxidizing agent. Okay. One example of mild oxidizing agent that you can write is Ag whole twice O. Right, next, second. From alkyl benzenes. Now in alkyl benzene, no matter what the alkyl group is, it doesn't matter whether you are having 1 carbon, 2 carbon, 3 carbon, 4 carbon, or 5 carbon atom, it doesn't matter. You are going to use KMnO4 in alkaline condition, KOH, and also use some heat. So first of all, this will get completely oxidized into carboxylate ion. Why carboxylate ion? Because it is in the basic medium. After hydrolysis in acidic condition, we are going to get carboxylic acid. And in this case, specifically, we are getting benzoic acid. Simply speaking, if you have, let us suppose toluene, and you first of all, you have alkaline, KMnO4, and heat. The second step, you are adding H plus or H3O plus. You will get benzoic acid. Right, the third method of preparation. From nitriles and amides. Okay. Now here it is same thing, both for both the cases. If you have nitrile, for example, R, C triple bond N, and you do acidic hydrolysis, for example, H plus in the presence of water, you will get R, CH2, single bond NH2. Wait a second. You will here get R, C double bond O, sorry, yeah. You will get amide, C double bond O and NH2. After this, you again do H plus or OH negative with heat. You are going to get R, C double bond O and OH. So both are hydrolysis reaction. 1 to 3 carbon atom, CONH2. If you have amide, then you will do H plus in the presence of heat and you will get COOH. This can also be used to prepare benzoic acid. If you have a benzene ring attached with CONH2, you just need to do acidic hydrolysis and heat it. You will get benzoic acid. If you have been given nitrile, for example, then here also the same thing. H plus, first of all, it will convert it to CONH2 and then heat. With H plus, it is going to convert to COOH. If there is no heat, then you will stop at amide. This is carboxylic acid. Right, the fourth method of preparation. From Grignard reagent. This Grignard reagent and the above case nitrile case is very important for organic conversion. Okay, so first of all, look at Grignard reagent. Why Grignard reagent is important? Because if you have RMgX and carbon dioxide, now in carbon dioxide you have oxygen double bond carbon double bond oxygen. Now this carbon atom is highly delta positive, and this R will be delta negative. So this R attacks on the carbon atom, and when it attacks, you are going to get this carbon atom attached with R double bond O, and one of the pi bond with oxygen will break. It will get O negative, and O negative will be neutralized by MgX. And on further hydrolysis, you will get R, C double bond O, and here you will get OH. So what is happening? We are starting with R number of carbon atoms, and we are getting R plus 1 carbon atom. Okay, so this is an important reaction of ascension. If you are going to increase the number of carbon atoms by 1, then this is an important reaction. For example, if you have CS3CH2, MgBr, in the first step you have carbon dioxide, in the second step you have H2O in the presence of H plus, then you are going to get 2 carbon atoms, CS3CH2, same thing, and then you will just add COOH. That's it. Okay, so just one more carbon atom. Please write carboxylic acid formed will have one carbon more than the Grignard reagent. No. See where this type of reaction can be used, right? For example, you have to convert ethanol to propanoic acid. Now, ethanol has 2 carbon atoms and OH. Propanoic acid will have 1, 2, 3 carbon atoms and C double bond OH. Now, we cannot go, if you see alcohol and you see alcohol and then you are seeing here what acid, then you cannot just go with a strong oxidizing agent. Why? Because if you use strong oxidizing agent, then ethanol will give you ethanoic acid, not propanoic acid. So for this, you need to increase the carbon number by 1. You know? First of all, you will convert ethanol to alkyl halide using SOCl2. It will give you chloroethane. Now from here you have two different pathways. You can either use Mg first of all to get RMgCl, and after that you will first of all do CO2, and then second you are going to give H2O in the presence of H plus. Okay, H3O plus in the acidic condition. Now, if you do this, you will get one more carbon atom. यहाँ पे दो carbon atom and तीसरा carbon atom is going to be carboxylic acid. Another way that you can use this is you react this with KCN, and then you are going to get third carbon atom will be nitrile, and after nitrile, you give it H3O plus in the presence of heat. It will convert this to carboxylic acid. Okay, so there are two different pathways that you can use. You can either go from after this the pathways change. You can either add magnesium and then carbon dioxide, or you can add KCN and then hydrolyze it in the acidic medium. Okay, please write this down. Sometimes they can also give you the starting material as chloroethane. So in that case, it will be easy. You can choose anything. This type of conversion in which the product is having one carbon more than the reactant, this type of conversion is known as ascent of carbon. Scroll up. Yeah, sure. Please write this down, guys. Let me know once you're done. By the way, how many of you gave the electrochemistry test? Raise your hand. Okay. And Real, Huzaifa and Maimuna, आप लोगों ने नहीं दिया. Why? Rishan also. Adril you gave. What about Rishan, Huzaifa? Huzaifa, आपने नहीं दिया test? And Maimuna, what about you? अच्छा दिया था. Okay. Maimuna, what about you?
Yes.
अच्छा, you also gave. Okay. All of you got the answer key also, right? किसी ने मार्क्स अपने चेक किए आंसर की से मिला के? नहीं. अच्छा, Ahmed, you did. How much are you getting, Ahmed? Actually, you did not check. Actually, you just gave. Okay, fine. All of you done? Yes or no? Please tell me.
Yes, sir.
Okay. Let me know if someone is writing. Right, next reaction from acyl halide. Here, when you have C double bond OCl, है ना? ये तो आप लोगों को पता होगा. This is C double bond OCl, and then you add water to it. If you do this in acidic condition, then it is going to be, or in neutral condition also, it is going to give you RCOOH. But if you do the same reaction in basic medium, that means hydrolysis in basic medium, you will first of all get RCOO negative, the carboxylate ion, and on further hydrolysis, it is going to give you carboxylic acid. Okay, so this acyl chloride is also nothing but just hydrolysis of acyl chloride gives carboxylic acid, nothing else. Right, next, sixth one from anhydrides. General structure of anhydride is something like this: R, C double bond O, oxygen, C double bond O, and some different R dash or same R dash. You add water to it, what is going to happen? You have HOH, right? ठीक है, तो एक तो ये bond break कर जाएगा, and then oxygen atom will get this hydrogen, this carbon atom will get this OH. So you will get R COOH plus इधर से आपको क्या मिलेगा? R dash COOH. So you'll get 2 molecules of carboxylic acid. Okay, you will get 2 molecules of carboxylic acid. For example, if you have C double bond O, oxygen, C double bond O like this, and here you have a benzene ring plus H2O. So you will get benzene ring and carboxylic acid attached, that is benzoic acid, COOH, plus you will get CS3COH. Right, the last one, 7th, from esters. Write it from anhydrides one, and then we'll write about from esters. Now, look at the reactions of esters. Ester have a general formula of R, C double bond O, OR dash. Okay, so this R, this part is responsible for same thing we are doing, hydrolysis in acidic medium, H3O plus. So this part, that is the red part. Red part पे क्या आ रहा है? देखिए carbonyl carbon आ रहा है जहाँ पे. So that will give you C double bond O and OH. Okay, the red part, wherever you have the carbonyl carbon, the alkyl group attached to carbonyl carbon, that will give you carboxylic acid, and this R dash here, which is directly connected to O, it is going to give you alcohol. So it gives two products, alcohol and carboxylic acid. So if you have tell me the carboxylic acid will be given by which group? The red one or the green one? Carboxylic acid will be given by the red wala or green wala? Which alkyl group is going to give you the carboxylic acid, red or green? Okay, I've got answer from Samira. Others, please answer. Okay, I've got two answers from Samira and then from Adriel. Waiting for others. देखिए लास्ट वाले में क्या हुआ था? Try to see the pattern here. Try to see the pattern and tell me the answer. Please answer, guys. Abdurrahman, Ahmed, Fahad, Huzaifa, Maimuna. Please answer. Look at the above one. Which fragment is getting the carboxylic acid? The one which is getting carboxylic acid. Yes, Abdurrahman correct. This will be R dash OH. इसको correct कर लीजिएगा. This will be R dash OH. I forgot the R dash. Now see here. Carboxylic acid will be made by that fragment which is having carbonyl carbon. So which fragment is having carbonyl carbon? The green one. है ना? Carbonyl carbon कहाँ पे आ रहा है? Green वाले के पास आ रहा है, right? So please write C double bond O and you will have OH plus CS3OH. Ahmed, your answer was wrong. I don't know why you answered that. After this, right? Physical properties of carboxylic acid. Right, the first line regarding boiling point. Carboxylic acid have higher boiling point. नहीं फहद आपका सही था, अहमद का सही नहीं. Your answer was correct, Fahad. Carboxylic acid having higher boiling point than corresponding aldehyde and ketones. Higher boiling point than corresponding aldehyde and ketone. And also alcohol. Why is that? Why is there why carboxylic acid is having higher boiling point than alcohol? Is right. This is due to extensive hydrogen bonding. So in carboxylic acid, you have C double bond O, and here you have OH, and here you will have hydrogen. Okay, so this is the structure of carboxylic acid. Now, hydrogen of OH is having hydrogen bond with C double bond O. Again, here also it is having hydrogen bond with C double bond O. Now, these are the two fragments. Okay, this is one molecule of carboxylic acid, and this is another molecule of carboxylic acid. And the hydrogen bond between them is so strong that if you heat it and it evaporates, then in vapor form also it is having the same structure. So it exists as dimer in the vapor state. Vapor state में जब आप देखिए carboxylic acid को, then it will be having the same dimer form. Okay, so please write dimer of carboxylic acid, and this is the shape of carboxylic acid, the structure of carboxylic acid in vapor form. So in 1 marks, they can ask you, draw the diagram of carboxylic acid in vapor form. Okay, and in aprotic form also. Now that means now carboxylic acid will be having the highest boiling point in all of the organic molecules, because यहाँ पे आपके पास क्या है, extensive hydrogen bond. Right. Next, regarding the solubility, aliphatic carboxylic acid are soluble in water as they form hydrogen bond with water. And they can easily form hydrogen bond with water. That is why they are soluble. But the solubility decreases as the number of carbon atoms increase in alkyl chain. And that is why benzoic acid, which is having 6 carbon atom, it is not soluble in water. Please write benzoic acid is not soluble in water. Okay. Also, last point, carboxylic acid are soluble in organic solvents. Such as benzene, alcohol, ether, chloroform, etc. Right, next, chemical properties of carboxylic acid. In this, the first very important one is acidic character. In acidic character, we'll first of all look at the reaction with metals and alkali of carboxylic acid. Okay, right, A part, a reaction with metals, and which metals? The wedding elements, hai na? Those are active metals and alkali. Now, if you have carboxylic acid and you treat this with sodium metal, which is an active metal, you'll get carboxylate ion and Na positive. So this is sodium salt of carboxylic acid or sodium carboxylate, and there will be liberation of hydrogen gas. And if you have carboxylic acid with NaOH, sodium hydroxide. Then again, you will get COO negative and Na positive, the salt, plus you will get water as the byproduct. Now you can also have with some weaker acids such as Na2CO3. This will give you RCOO negative, Na positive, plus H2O, plus CO2. Okay, so what in all of these cases, you are getting the sodium salt of carboxylic acid. Okay, so these are the three reactions. Now, the more important part is the acidic strength. Why is something even acidic in nature? It is acidic in nature because it can liberate H plus ion. Okay, so what happens if carboxylate ion liberates H plus ion? Please see. If you have RCOO negative, sorry, RC double bond O and OH, you react this with water. In the presence of water, it is going to liberate H plus ion. That is why it is acidic in nature. What happens to water when it gets H plus ion? It converts itself to hydronium ion H3 plus, H3O plus, and we get R C double bond O negative. Now this carboxylate ion is resonance stabilized. That is why it can easily liberate the H plus ion. Okay, that is why it can easily liberate the H plus ion. It can release the H plus ion. So please write carboxylic acid dissociates in water to form a resonance stabilized carboxylate ion and hydronium ion. Hydronium ion is H3O plus. Okay, that is the reason. So that means whatever you are going to form after liberating H plus ion, that should be stable. This is your acid, and this is also known as conjugate base. So if your conjugate base is stable, that means acid is going to be stronger. Okay, acidic character will be high in that particular acid. The conjugate base should be stable. What is conjugate base? Whatever you get after removing the H plus. So you have carboxylic acid, that is an acid. You remove the H plus ion, you get RCO negative carboxylate ion. That is my conjugate base. My conjugate base should be stable. Now, how to define the acidic strength in numbers? So for this, we use chemical equilibrium. Now, what is K equilibrium? K equilibrium states that it is the ratio between the amount of concentration of product by concentration of reactant. Now, in our case, the product is RCOO negative and H3O positive. The reactant in our case is the carboxylic acid RCOOH and H2O. Now, since water's concentration is not going to change, it is a constant, we can keep it with this constant of K equilibrium. So K equilibrium times H2O, it gives you Ka. Okay, and this will be equal to the same thing. Oops. Except the H2O. Okay, because H2O is already taken to the left hand side. Now please see, if we have more H plus ion, so the amount of product will increase, right? If the amount of product increases, the Ka also increases. So if you have high Ka, that means strong acid. Okay, that means strong acid. But we don't use Ka, we use pKa. What is pKa? pKa is minus log of Ka. Okay, minus log of Ka. Now, if Ka is going to be high, this whole quantity is going to be low, and that is why strong acid have lower pKa values. Okay, it will have lower pKa values. If you want to look at the range, if you have pKa that is less than 1, it is going to be a strong acid. Between 1 to 5, it is going to be moderately strong acid. And this is the range of carboxylic acid. Okay, this is the range of carboxylic acid. If you have 5 to 15, this is going to be a weak acid. Please remember, this is not pH, this is pKa, so it is not going to end at 14. Okay, and if you have pKa that is greater than 15, it is going to be extremely weak acid. Our carboxylic acid lies in this 1 to 5 range. Its typical pKa is 4 point something, depending on the substituent. Write this down. After this, we will compare the acidic character of carboxylic acid and phenol. Okay, please write. Carboxylic acid versus phenol. So please see. Now we all know that it will depend on the stability of the conjugate base, है ना? तो carboxylic acid का conjugate base क्या होता है? The carboxylic acid is R C double bond O OH. In the presence of water, it will leave H plus and it will give you R C double bond O negative, right? And this is going to be in conjugation with this another oxygen atom, and it will give you R C double bond O. Sorry, this will now be O negative, and this will be double bond O. What about phenol? If you look at phenol, in the presence of H2O, it is going to give you phenoxide ion. That means this oxygen here, it will contain the negative charge. Okay, now this can also show resonance like this. Okay, now look at these two structures here. Okay, so if you look at the number of resonating structures, then who has the larger number of resonating structures? Tell me, guys. Phenoxide ion or the carboxylate ion? Which has more resonating structures? Tell me.
Peroxide.
Phenoxide ion. So on the basis of the number of resonating structure, which will be more stable? Phenoxide or carboxylate? On the basis of more number of resonating structures, which will be more stable, phenoxide or carboxylate ion?
Peroxide.
No, phenoxide ion. But still carboxylic acid के नाम में acid है, phenol के नाम में acid नहीं है. That means obviously carboxylic acid is more acid. But why it is more acidic? There are two reasons. Number one reason is, in both of these structures are completely same structures, right? That means the negative charge is of the same atom, oxygen. Okay, so this type of resonance is known as equivalent resonance, and these are having more stabilizing power. Equivalent resonance. यहाँ पे क्या है? This is non-equivalent resonance. Next thing is, where is the negative charge in carboxylate ion? It is on oxygen. So please write negative charge is always on oxygen. Always on more electronegative oxygen atom. What about phenoxide ion? In phenoxide ion, the negative charge is in carbon, again carbon, and again carbon. So most of the time, the charge is on carbon atom. So you write negative charge is mostly on carbon atom. Therefore, carboxylate ion is more stable than phenoxide ion. Making carboxylic acid more acidic than phenol. Okay. मोस्टली ऑन ना, यहाँ पे ऐसे लिख दीजिएगा, कार्बन आटम नहीं लिखिए, लेस इलेक्ट्रोनेगेटिव कार्बन आटम लिख दीजिए, लेस इलेक्ट्रोनेगेटिव कार्बन आटम. After this, you will write effect of substituent, C part in acidic character. Effect of substituent. All of you wrote the above part? Anyone still writing? Please let me know. See here, acidic strength of carboxylic acid is directly proportional to, we saw now, stability of carboxylate ion. Stability of carboxylate ion. Now my carboxylate ion is both of will be having delta negative, and this will be in resonance like this. Now, if I have negative charge on the oxygen atoms and I attach an electron withdrawing group here, then this electron withdrawing group is going to pull the electrons and get the charge density lower. Okay, it will decrease the charge density. So what is going to happen if I have electron withdrawing group? It will pull the electrons. So charge density decreases. If the charge density decreases, stability will increase. Stability increases, then acidic strength increases, and pKa value will decrease. If I attach an electron donating group, on the carboxylic acid. Now the carboxylate ion will have increase in charge density. Stability decreases. Acidic strength will also decrease. And pKa will increase. Right, next. Order of electron withdrawing groups. Okay, so if there is a carboxylic acid attached with phenyl, then phenyl is also going to pull electrons. Then you have iodine. Then after iodine, we have Br. Then we have chlorine. Chlorine has higher electron withdrawing capacity, followed by nitride, followed by nitro, and then followed by trifluoromethyl, CF3. Okay, so if CF3 is present, that is going to pull the electron most effectively. Right, a question. Which acid in each pair will have higher pKa? So here, first structure we have C double bond O, OH. This is the first structure. Okay, as I लिख space. This is one ka A, and this is one का B structure. ठीक है. सेकेंड में आपके पास है 1 2 A and B. थर्ड में आपके पास 1 2 3 4 5 क्लोरीन इन दिस कार्बन एटम, दिस इज A, एंड इसमें B है आपके पास 4 carbon atoms and the fluorine is here. Okay, fourth का स्ट्रक्चर आपको दिया हुआ है. So just tell me which will have higher pKa. आंसर कीजिए आप लोग. Which will have a higher pKa? फर्स्ट में किसका हायर होगा, सेकंड में किसका हायर होगा, थर्ड में किसका होगा, फोर्थ में किसका होगा. We'll give you guys 5 minutes. Send the answer on my Zoom chat only, okay? If you want, you can send on WhatsApp also. Jiva, your first answer is wrong. Samaira, both of your answers are right. Very good. Abdurrahman, your answers are wrong. All three are wrong. See. पीके के लिए आपको ये भी पता होना चाहिए कि किसका एसिडिक स्ट्रेंथ और पीके में क्या रिलेशनशिप है. In this case, you first of all tell me the acidic strength. Abdurrahman, tell me acidic strength किसका ज्यादा होगा, A या B का? Yes, Abdurrahman, acidic strength किसका ज्यादा होगा, A या B? Abdurrahman, turn your mic on. Turn your mic on. Yes, Abdurrahman. Whose acidic strength will be higher, A or B? जोर से बोलिए ना, जोर से. हाँ, A का. Keep your mic on. Keep your mic on. Keep your mic on. Yes, now tell me. Acidic strength of A will be higher. Why? What does electron withdrawing group do to acidic strength? Acidic strength बढ़ाता है, घटाता है?
Increases.
इंक्रीज करता है. तो बताइए इलेक्ट्रॉन विड्रॉइंग ग्रुप कहाँ पे है, ए में है या बी में है?
डी में.
तो फिर एसिडिक स्ट्रेंथ किसका ज्यादा होगा?
ए का सर.
किसका ज्यादा होगा? वंस अगेन अब्दुलरहमान, क्या बोला आपने? कैन यू रिपीट दैट?
ए का. ए.
अच्छा, फिर से पूछते हैं, इलेक्ट्रॉन विड्रॉइंग ग्रुप अगर प्रेजेंट होता है तो एसिडिक स्ट्रेंथ इंक्रीज करती है या डिक्रीज करती है?
इंक्रीज करती है.
क्या होता है, फिर से बताइए. इलेक्ट्रॉन, पूरा पूरा सेंटेंस बोलिए खुद से एक बार.
Electron withdrawing group, if it's present, then acidic strength increases.
Okay, which has electron withdrawing group, A और B?
B.
ठीक है, B के पास क्या है?
Electron withdrawing group.
तो एसिडिक स्ट्रेंथ ज्यादा या कम?
More.
तो किसका ज्यादा होगा, A या B? इलेक्ट्रॉन
B.
एसिडिक स्ट्रेंथ.
B.
आप A क्यों रट लगाए हुए थे? थोड़ा ध्यान देके दीजिए, ठीक है ना. आंसर खुद ही किया है आपने, बस ध्यान नहीं रह रहा है, या तो आप हड़बड़ा जा रहे हैं. एसिडिक स्ट्रेंथ किसका ज्यादा होगा यहाँ पे, बताइए अब्दुलरहमान. ए या बी का?
सेकेंड वन में.
फर्स्ट में किसका होगा, ए का या बी का? फर्स्ट की बात कर, बी का. तो पीके किसका ज्यादा होगा? एसिडिक. सेकंड वाले में बताइए एसिडिक स्ट्रेंथ किसका ज्यादा होगा?
तो बी.
देख के बताइए.
ए का सर.
ए का क्यों ज्यादा होगा?
तो फ्लोरीन का ज्यादा है सर.
फ्लोरीन हैज अ ग्रेटर कैपेसिटी टू विथड्रॉ इलेक्ट्रॉन्स, करेक्ट. तो पीके किसका ज्यादा होगा?
बी.
व्हाट अबाउट द थर्ड केस, एसिडिक स्ट्रेंथ किसका ज्यादा होगा, ए या बी? यहाँ पे बहुत लोगों को कंफ्यूजन हो सकता है. बोथ ऑफ देम आर हैविंग फ्लोरीन, ओके, बट इन ए स्ट्रक्चर फ्लोरीन इज 1 2 3 4 carbon away from carboxylic acid, and in B it is only 3 carbon away. So if fluorine is nearer, then the acidic strength will be higher. So acidic strength will be greater of B, because fluorine is near to the carboxylic acid and it can pull the electron more effectively. And pK will be of A. Jiva, turn your mic on. Jiva, can you hear me?
Yes, sir.
So can you explain this one, sir?
Sorry,
So can you explain this one, sir?
which one? Third one?
Yes, sir.
Okay. आप अच्छे से पुल कहां से कर सकते हैं बताइए? If you hold A part or the B part, what do you think? Where can you pull
B part.
B part? So here fluorine is more near to carboxylic acid. Now that is why it can pull the electrons more effectively. If it will pull electrons more effectively, then what will happen? The acidic strength will increase. बात आ गई समझ में? Abdurrahman?
Yes, yes, sir.
Okay. Jiva, I'm asking about the first one. You have to look at the electron withdrawing group. Where is the electron withdrawing group, in A or B? I can't hear you. In A or B, which is having electron withdrawing group? Can anyone hear Jiva? Fahad, Abdurrahman, anyone can hear? Can anyone hear Jiva? No. See, Jiva, here we have fluorine, which is an electron withdrawing group. It will pull the electrons from carboxylic acid, making it more acidic. Please listen then. Fluorine is electron withdrawing group. It will pull electrons, making it more acidic. If you are going to have electron withdrawing group, यहाँ पे हमने बताया था, if you have electron withdrawing group, then the acidic strength increases and pK decreases. Okay, so here B is going to have more acidic strength and less pK. So A will be having higher pK. Acidic strength or pK may inversely proportional relationship. In the fourth structure, as you all can see, here we have CF3. That means if I talk about acidic strength, A will have higher acidic strength and the pK value of B will be higher because it is less acidic. Please write the answers. Is everyone done? Shall you write next? Formation of anhydride. Second chemical property. Formation of anhydride. If you have carboxylic acid such as ethanoic acid, then two molecules of ethanoic acid, they will react and they will give away water in the presence of H plus and heat or P2O5 and heat, and they will form anhydride. Okay, CH3. This H2O is leaving from here. Okay, H2O is leaving from here. You just need to, after that, combine this carbon with this oxygen. So in general, if you have R, COOH in the presence of P2, this is O5, and heat, you are going to get R, C double bond O, O, C double bond O, and R. All right, third reaction. Formation of esters. Formation of ester is the reaction with alcohol. So if you have R, COOH plus R dash OH, then in the presence of H plus, it is kind of a reversible reaction. You are going to get R, CO, OR dash. Okay, so for example, you have 1, 2, 3 carbon atoms COOH, plus you have 2 carbon atoms with a OH group. So here we have propanoic acid, here we have ethanol. Then in this case, you will get 1, 2, 3 carbon atoms with a double bond O, followed by oxygen, and then followed by the 2 carbons of ethanol. Okay, so this is 3 carbon atom, this is the 3 carbon atom. And then here you have this. So these are the 2 carbon atoms of the ethanol. So alcohol and carboxylic acid, they form esters. Like the fourth reaction, formation of acid chloride or acyl chloride. Formation of this reaction is very similar to the reaction of formation of haloalkane. And in haloalkane, we use multiple phosphorus-based reagents and also one thionyl chloride. Okay. So if you have R, C double bond O and OH, alcohols to haloalkane, similar type of reagents are here. If you use PCl5, this OH will be replaced by chlorine. R, C double bond O is as it is, it will be replaced by chlorine. Plus you will get POCl3 and HCl as the byproduct. Similarly, you can use PCl3. You will again have RC double bond O as it is, OH will be replaced by Cl, plus we will have H3PO3. Then at the end, you have SOCl2. Here you have R, C double bond O, again Cl, plus SO2 and HCl. Right, next, formation of amides. If you react carboxylic acid with ammonia, now ammonia is a base, it will attack on the H of hydrogen atom of carboxylic acid, and it is going to form salt, that is R, COO negative, NH4 positive. Now, heating of this salt gives out water, and you get R, C double bond O, and you get NH2 here. Okay, so first of all, we have ammonia, and then we heat it to get amide. For example, if you have 3 carbon atoms of COH, in the first step, you give NH3. The second step, you heat it. Then you are going to get CONH2. Now, in this, there is an important reaction, formation of phthalimide. Formation of phthalimide starts with a benzene ring with 2 carboxylic acid group in ortho position. And first of all, we react this with NH3. Now here it is going to form new salt. That is the benzene ring. COO negative, NH4 positive, COO negative, NH4 positive. And once you heat it, you will get water will be liberated and you will get amide in both the cases. This will convert to COO, NH2, है ना? इस तरह से. See here. Double bond O, NH2, NH2, and here you will have double bond O. Now, once you heat this one more time, and this will be extreme heating, this will liberate NH3. Okay, so nitrogen, 2 hydrogens and 1 hydrogen from here. And there will be a ring formation like this. Nitrogen and 1 hydrogen will be remaining. This double bond O is as it is, and this double bond O is as it is. This is phthalimide, PH, TH, LI, MIDE. Phthalimide is used for the preparation of amines that we will learn in the next lesson. In amines chapter, we will learn that phthalimide can be used to form primary amines. Write this down. The reaction is simple. NH3, it gives you salt. Heating gives you water. Once again, heating gives you NH3. Right, the sixth reaction, reduction of carboxylic acid. Carboxylic acid can be reduced by 2 different reagents. One is lithium aluminium hydride, and reducing this is going to give you alcohol and also 1 degree alcohol, RCH2OH, 1 degree alcohol. Another reducing agent that we can use is, after LiLH4, you need to do acidic hydrolysis, H3O plus. Similarly, you have B2H6 diborane, and then the second step is 3O plus. Here also you will get alcohol, RCH2OH. That is 1 degree alcohol. One thing very important to remember is that if you react carboxylic acid with sodium borohydride, NaBH4, then this will give you no reaction. Sodium borohydride cannot reduce carboxylic acid because it is a weak reducing agent. The seventh reaction, decarboxylation. In decarboxylation reaction, you see, we react RCOONA, that means sodium salt of carboxylic acid. This sodium salt can be made by either reacting carboxylic acid with sodium hydroxide, or Na2CO3. All of this is going to give you what? RCOO negative and Na positive. Then you treat this with soda lime. Soda lime is a mixture of sodium hydroxide and CaO. Okay, we heat this with soda lime to get RH plus Na2CO3. Okay, what is important that you can see here we have R and 1 more carbon. Here in the alkane, that is RH, we are getting what? Only R carbon. That means there's a descent of number of carbon atoms. So if I start with propanoic acid, NaOH plus calcium oxide, in heat, I will get only ethane molecule, CH3. This carboxylic acid will be decarboxylated. Right here, NaOH plus CaO in 3:1 ratio is called soda lime. Write the eighth reaction. Hard Zielinski. Also known as HVZ reaction. In this reaction, you should have at least one alpha hydrogen. That is, you should have R CH2 C double bond O COOH. You react first of all this with chlorine or bromine in red phosphorus. That is X2 in the presence of red phosphorus. And after that, you add water to it. You will get R. One hydrogen will be replaced by bromine. Oh, sorry. You can take any halogen, no? Bromine or chlorine, X. So for example, in the presence of Br2 and red phosphorus, secondly, water, everything will be as it is. The second carbon atom is going to get Br. Similarly, you can have chlorine in the presence of red phosphorus. Secondly, water. Everything will be same. The alpha carbon is going to get chlorine. Okay, this is the alpha carbon. 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 Okay. I'm just noting you guys that substitution is taking place at alpha carbon. Please write. Alpha carbon should have at least one hydrogen. In homework, you will write the two electrophilic aromatic substitution reactions of carboxylic acid. Okay. Write this down. You know once you're done.